going on with the recording?
Yes.
Yes. Septimus is also recording. Septimus is from Token Engineering Commons, and perfect. So short intro. I am working on curating this book, A Hitchhiker's Guide to Token Engineering, and it's a community-sourced and community-funded book on token engineering. Heavily worked on the chapter Token Model Generation for the past year, and basically one of the chapters is, other chapters is the transdisciplinary art of token engineering, which is this one. And yeah, Shermin is going to talk a bit more about that and her background. But before that, this is what I'm currently working on that's relating to token engineering. I am helping out or actively designing in 2 other protocols right now, or communities, which is one, Data Art Invisible Economy, and Boson protocol, the Things Economy, so complementary opposites. Yes, and basically, I met all of you in many different in many different venues, but I met the newest Lisa on Twitter, where I also met a lot of people with respect to token engineering, cryptoeconomics. And Lisa is, as I mentioned, has published a book and has been around for a couple of years. She's currently living in Singapore, and we're hacking further ideas on books and publishing and token engineering. So Lisa, please share a bit what you're currently doing, and if you can connect to the next person, would be great.
Yeah, absolutely. So thank you for having me. Really excited to be having this chat, this little chat that we've been talking about for some time now. So on the works relating to token engineering, I think the 3 main things that I'm working on, the first one is an academy. So making this, because this space, as we're going to talk about later, it's really transdisciplinary. And this is something that the schools just don't teach. And it's really difficult because the curriculum is very stuck in the old school world where you're just specializing in one field. But as you come into the space, you realize that people are, basically everyone's a polymath. They're good in a lot of different fields. And it's not just a specialization that gets you somewhere. You actually need to have some form of specialization and generalization. So that's what I'm looking to build. And I've got a few courses out already, just educating people and bringing people on board. Once they come on board with the foundational level of transdisciplinary skill sets, then they can go and deep dive into very specific kind of skill sets, like being an expert in CAD, being an expert in community management or whatever. But the baseline, we have really increased the barriers to entry and making sure that you need to have some form of understanding in different kind of disciplines. So I'm working on an academy. The second thing is we're working together with Sebnem as well. We're looking at using NFTs to experiment with different licensing rights, because I think NFTs are so much more than just art and things. If we can embed different intellectual property and different kind of legal rights into an NFT, instead of just signing a piece of paper and allowing the paper to enforce your rights in different jurisdictions, NFTs can be a way to do that. And there are a lot of interesting economic models that's out there. And it's so fun because during the lockdown or since 2018, there seems to be a lot of new models coming out, a lot of new models being trialed and tested in the academia world, but we really can't get empirical study or empirical data to test if they're real or not, or to test how efficient they are. So now it becomes a very interesting way to start experimenting and not just bridging in the interdisciplinary way, but bridging between the theoretical and practitioner way. And that's fascinating. What a time to be alive. And the last thing is also modeling some form of economic logic. I know we have CAD that is running some form of simulation to understand the economic interaction and mechanism design of different economic agents and how they behave. That's amazing. That's completely beautiful. And one of the things is that it is still quite complicated. So it's not as easy to to become a master in CAD/CAD so quickly. And it might take some form of engineering perspective or some form of computer science experience for someone to really fully understand and grasp CAD/CAD. It's a very, very powerful tool, but it's not as used right now. So before we move there, I'm just looking at just very, very simple way of modeling economic logic, modeling people's behavior, modeling different kind of interaction between economic agents in Excel, just a very simple one, before we move forward towards the whole complex models in CAD/CAD. So these are some projects I'm working on. These are internal projects, and then there are a lot of clients that I'm working on, a lot of models that we're building, a lot of interesting things that we're playing around with. It's a very, very fascinating time to be alive. So I'm going to pass the bat to who should I pass it to? Let's see. Maybe I can pass it to, I'll pass it to Shermin. Professor Shermin, so bright, and she has amazing paper, amazing book, Token Economy, highly recommended on Amazon. And she has been working together with Zargam on a lot of different papers, a lot of interesting models coming out, and they're working a lot also on the theoretical side, very beautiful models. So Shermin, introduce yourself, please.
Thank you, Lisa. I'm a big fan of your work too. I'm not a professor. I'm barely a doctor, apparently. And yeah, I've been working on this field, and a lot of the things that you mentioned are true, especially when it comes to the lack of interdisciplinary thinking, especially in academia, not only in research, but also in education. This is one is really difficult. And I started the Blockchain Hub back in 2015 in Berlin, with the aim to do some interdisciplinary approach on this new emerging technology. And we did it privately funded for a few years. It was a private initiative, self-funded, and we had a lot of working groups out of practitioners in the field who were interested to understand what is this blockchain thing anyway, right? This Web3 blockchain thing. And then I got this amazing opportunity to go and build a research institute in Vienna that we called the Cryptoeconomics Institute early 2018. My vision back then was to create a research institute that is interdisciplinary, because I saw the necessity to look at this new emerging technology, not only from a technological perspective, because technology in the end is always just a means to an end to shape socioeconomic systems, right? Especially internet-based technologies. So we try to build an institute on the intersection of startups and science, because there's a lot of scientific knowledge that is actually needed to flow into the token engineering process of designing these token ecosystems. And while that was a great opportunity, it was hard to beat the system, and academia, unfortunately, is still stuck in disciplinary thinking, because the incentive mechanisms are very disciplinary, and because the process of interdisciplinary publishing is also slower and messier. It's not as fast, I guess. So while we had a support from many people, we had researchers from many fields who were part of our institute, but most of them were tied up like as kind of affiliated researchers, but they were tied up in their own disciplines. While they were interested, they had little bandwidth to contribute. And even if they had the bandwidth, they were still thinking very often in their disciplines. Either it was computer science or network science, or it was economics. And even if they were economists, they would say, but I'm not a macroeconomist. I'm only a microeconomist. And I don't know game theory. I only know whatever. You know, it's like, I'm only in finance. And I'm like, yeah, but you know, it's like, so that was quite a challenge to try to set up a research institute that tackles the necessity of defining the research areas in this field. I think when Zargam came on board as an affiliated researcher, he brought this practitioner outside perspective while he had a strong academic background. Zarkem and Jamshid Shorish that I brought on board, they were researchers that I had left academia, probably for the same reasons that I had left years before, because it was too disciplinary. And together we started publishing papers, and one of them was the Foundations of Cryptoeconomic Systems. I'm not at university anymore. Right now, I started Token Kitchen as more applied, hands-on research and education and consulting institute to help shape tokenized ecosystems, more less kind of asset-backed tokens, but more these what I call purpose-driven tokens, tokens that steer economic systems. And I'm currently writing my second book called Purpose-Driven Tokens, and it will be a kind of handbook of token use cases. So we can learn by copy pasting existing or emerging kind of purpose-driven use cases, tokens that steer DAOs, collectively create a public infrastructure such as, I don't know, telecommunication networks, or tokens that incentivize biodiversity, CO2 emission reduction, et cetera, et cetera. So the question of how can we incentivize individual action towards a collective good is in the focus of my research. And in that, I focus on the economic engineering of it. So the ecological engineering, the macroeconomic engineering, the behavioral economics behind this, not so much the techno-legal questions that are also very important, but then people, associates or like partners of us would do that. So I think I should pass on to the next person and we will discuss in depth more. Yeah. I think I want to pass on, it's difficult. I think Wassim would be, I'd like to pass on to both Trent and Wassim. I will pass on to Wassim because he was actually also on the forefront of creating this new journal of cryptoeconomics where we met. And Wassim, please introduce yourself.
Sure, thanks, Shermin. Hey, everybody. Yes, I'm Wassim, and yeah, my journey's been kind of long and winding, like I guess a lot of ours has. And the way I kind of tripped and fell into, I guess, token engineering was a few years ago. I was an independent researcher in the space. So I was running a consultancy called Parallel Industries. We were writing papers, and I didn't know what I was doing at the time. But later I look back, and it was this extremely unusual kind of mix of disciplines. What I think I was doing was mixing like applied philosophy, epistemology, and empirical analysis, like data science, which like these are really not things that they're very seldom smashed together. And I was sending these papers to computer science conferences. So we're talking about disciplinarity. I was sending these weird papers about like kind of Shakespearean epistemologies of forks and like try to look into the future of these time machines to computer science conferences. And they were saying, this is not computer science, go away. So that was my first experience of the kind of disciplinary gates and barriers in the more scholarly side of this field. And so after that, I started working on something that I thought would be a bit more useful. And I wrote this kind of book monograph called Token Space, which is kind of like a set of epistemological tools to try and disentangle the different kind of, to get fine-grained characterization using things like taxonomies of different characteristics of cryptographic assets, networks, and tokens. Because if you remember back in 17 and 18, we were all kind of, the regulators and lawmakers were kind of saying, hey, look at this thing called Bitcoin, look at this thing called ICO coin, they're the same. And we were trying to find ways that we could disentangle these things. But the big problem we always hit up against, which I'm sure we'll talk about a lot today, is communication, just communicating across barriers, across fields, people from different training or even different like real, languages, if we're not all speaking we're speaking English today, but it may not be a lot of our first languages. So just the way to find common languages was one of the biggest challenges I kept butting up against. Trying to build a tool that token engineers like ourselves could use, that regulators could use, people that don't have computer science backgrounds, people that are cryptographers. How can you find common languages? So I built this kind of visual framework to convert this like taxonomies into these vector space representations. And you could kind of squash objective and subjective stuff into a picture, basically. And then you could show that to people and explain your reasoning and so on. So that was a couple of years ago, and I had to rush finish that. It was almost exactly 2 years ago, because I got a job working at MIT, the Media Lab, to launch their interdisciplinary cryptoeconomics and blockchain journal, which we call Cryptoeconomic Systems. And so this explicitly, my job was to help build the field, go around, meet all the people from these different kind of silos, this, you know, the economics faculty, and then the tower of lawyers, and then the media lab kind of weirdos, and then the computer scientists and the cryptographers. So my job was literally to go around like an emissary with a little white flag, trying to learn how to speak everyone's languages so that we could get them in the room together. And not only that, not only the disciplinary lines, but there's also a crazy line between Bitcoin and not Bitcoin. And this is also like, I mean, so I don't think there's many kind of like really like committed Bitcoiners in the room today. So I was trying to bridge this gap between the kind of people that are working on Web3, token engineering, cryptoeconomic stuff, the more kind of general purpose uses of blockchains and what have you, with the really kind of hardcore Bitcoin world, you know, which is like a lot of the history of this field comes from there. A lot of innovation is still happening there despite the technical limitations. And we were trying to find ways to, normally these two communities are very separate. So we're trying to find ways to bring them all together. So anyway, yeah, we started the journal. We did that. We did some conferences. So Shermin and Michael Zargam spoke at, actually, do you speak at, Zargam spoke at the second one. You didn't make it because of the pandemic, yes, but you had papers accepted at both conferences that we did in October 19 and March 20. And the first issue of the journal came out with your paper in it, Foundations of Cryptoeconomic Systems, very recently. I've now moved on. So I now work at another journal at the Media Lab called MIT Computational Law Report. Now you'll notice that the word law is in that journal. And like, I know nothing about the law, but somehow I am the editor, technology editor of this law journal, which I guess speaks to this unaddressed need in academia for people that can traverse boundaries. So the idea is we're now like at the interface of Civica and Legis, trying to find like what's coming now, next for law, next for computational regulation and law. And so now my job is to go even further than that. I'm like kind of peering over the event horizon into this black hole of just crazy stuff and trying to see what is eventually going to get dragged back to the frontiers. So that's quite exciting. I've got a monthly column starting there quite soon. So we'll be talking about a lot of the interesting things that we'll talk about today. And the last thing I'll say, sorry to take so long, is that about a year ago, just before the pandemic started, we started this loose collective organization called the 0x Salon, which is kind of this event series for regular discourse. And this is literally explicitly a post-disciplinary, transdisciplinary, like epistemic anarchy activity. Like we're literally trying to smash down the kinds of epistemic boundaries you can see behind me. And we're bringing people from like everywhere, from like category theory and mathematics to law, to philosophy, to design theory, to architecture, from everywhere, and putting them in a room, sometimes in real life, sometimes virtually, given the circumstances. And we are like shooting the shit, literally, you know, talking through the stuff, trying to disentangle some of these knotty topics. And so I can, we've had 20 of those so far. And so, and many of them are on similar topics to do with straddling disciplines, epistemic trespassing, all this kind of other kind of turns of phrase, which will hopefully feed some of that, the collected wisdom into our conversation today. And I will pass it to Trent, the man who needs no introduction.
This is amazing.
Well, thank you.
Trent.
Overall, like, yeah, it's awesome to be here, guys. And there's so many, you know, great minds in this room. So very cool to be here and share thoughts and ideas. Some sort of quick background on what I've done that kind of relates to token engineering and where I'm headed. I started studying engineering in 1994, so I'm old, in Canada. And I also did a computer science degree in parallel. And even interestingly, back then, there was a big battle about, the university was introducing software engineering. And they were there was a battle between the engineering department and the computer science department about who gets to do software engineering. And really, truly, there was no good answer because most of the engineering professors didn't really know code. And most of the computer science professors didn't know engineering. They just knew like the theoretical stuff. So in the end, actually, a good solution was arrived at, which was they worked together after about a year and a half of battling. So, but it does point to that, you know, there is a distinction between a science and an engineering and art, right? The goal of engineering is to produce artifacts that work and design, maintain, et cetera, them. The goal of science is the KPI is knowledge, right? But of course, science can inform engineering, and engineering often makes amazing tools to help push science forward. And engineering does include theory and practice and tools. And actually, a really, really key thing that was drilled into me even when I was young was the sense of responsibility and ethics. And some engineering courses have that. mine did. I'm really thankful that it did, because it kind of firmed up my resolve around that, and hopefully more will in the future. And honestly, hopefully more fields will, right? Why, you know, and many have now, right? We're seeing it in other fields, of course, too. So that was my start. Then for almost 20 years, I was in the world of AI and semiconductors at once. I was building CAD tools for designing computer chips for the likes of TSMC, Sony, Qualcomm, Apple, these folks. And the CAD tools had AI under the hood. The word AI was a swear word throughout the 2000s, so we never ever said that publicly in those conferences. Although I would show up to AI conferences and say, hey, we have a real world use case. And everyone would be like, oh, wow, look at this, look at this. So, you know, in that, I got a lot of experience with analog circuits. That was the focus, you know, really heavy duty dynamical systems, right? Optimization, statistics. I was doing it sort of 1 foot in academia, 1 foot in industry, and also via startups, you know, startups working with enterprise, et cetera. The AI side that I liked the most was actually genetic programming, which is simulated evolution of computer programs, which is about the most general thing you can do, because evolution is super general. And computer programs is sort of a superset of every other sort of entity. So you can do lots of cool things there. By the way, you can, this includes evolving solidity code and EVM code, bytecode. That's another story. Then I got into blockchain, started playing in 2010. 2013, I started in earnest a project for IP on blockchain called Ascribe. As far as I know, it was probably the world's first, you know, IP platform for blockchain, world's first NFT platform with licenses. Who knows? But it doesn't matter, right? Like overall, we did something cool. We got scale. We ran into scale issues. So we built BigChainDB, a scalable blockchain database. And as we were going along, you know, we had all these POCs, et cetera, you know, dozens of them. We got profitable, all that. But it was really a tough slog to go from private POCs to things that were actually deployed in real life. And that's when we started realizing that public permissionless is really useful, like really starting to grok that, as well as tokens. And actually, Joel Monegro sat me down one day and said, Trent, you've got to shut up. Let me talk, give me 2 hours at least, and I'm going to teach you why you need to really get tokens. So I shut up and he taught me, and that changed my life. So thank you, Joel. He's not in this call today, but he's had a big contribution to the field too, of course. So he taught me about the power of tokens. And from that, I started thinking about it a lot more and realizing that, you know, tokens are a way to get people to do stuff, right? Bitcoin gets people to secure the network by simply paying them in tokens. And I started to use this and to design Ocean. You know, we were pivoting towards Ocean because, you know, we saw that this was, you know, we wanted public permissionless scalable. We could draw on all of our experience in IP and data and so on. And we saw all these big problems in the world related to sharing data. So I started designing this, and I was frankly flailing. So I started to find some patterns that worked, drawing on my past experience in optimization. And I started writing about it. And right before I published the blog posts, you know, it was initially one huge blog post. I split them into 3. Right before I published them, I decided to just call it, you know, at first I had some big long title for it, and I even have some early talks on that, but I cut that out and I just called it token engineering. Just like, you know, electrons flow through electrical circuits, tokens flow through token circuits or tokenized ecosystems. And that's why. And engineering, of course, because I really do want it as an engineering discipline. And I wrote about it and, you know, my flailings and some early patterns that I had and ideas. And I love that this has taken off. And of course, I wasn't the first person to do token engineering. I just happened to give it a label, and there's a lot of great work that came before and a lot of great work that has come since. And, you know, and very quickly after I started writing about it, that's when I got connected to Zargum. And, you know, we struck it off and started to do a lot of stuff. I already knew Sebnem and many of you and Shermin and others in the room, of course. So that was all very helpful. So then I went back to the Ocean drawing board, used these patterns, designed Ocean first cut. I'm pretty proud of that design. Shipped Ocean, and for the last 3 years have basically been focusing on shipping Ocean, but continually refining the token engineering design, especially the last year and a half. About beginning of 2020, we did a revamp of the Ocean token design from a system level, as well as for the building blocks, because, you know, you can apply hierarchical design methodologies, and that's how you get, you know, a larger, more complicated system, complicated, not complex. And there's a big distinction. We should talk about that at some point too. Yeah. And so a more complicated system, and then also towards this, writing down the, you know, a step for each of these blocks at the system level and each block level, the steps of writing down the goals, doing the design, doing the verification, In some cases, just spreadsheet-based verification. In some cases, using agent-based verification. I whipped up my own simulator called Token Spice, which is agent-based Python, but you don't have to write differential equations. So, you know, it's kind of fun. And now it has EVM too, by the way. And then the block level goals for Ocean Market, which has AMMs, and Ocean DAO, which is more grants, riffing on the Dash design. So that's kind of the work. These days, the thing that's taking my time in the last few months is doing some token engineering tuning in Ocean. Helping bring token engineering to other projects that we collaborate with, such as a German automotive alliance called Katina X, which is part of Gaia X. Web3 projects on the side, you know, helping with Boson and some other ones. And actually NFTs as well. So Ocean itself actually does have licensing and legals for IP. Every ERC20, if you have 1.0 of those ERC20 tokens, it means you have a license to use that. And the base IP is actually represented as whoever is the owner of that ERC20 contract deployed. And so it's pretty interesting. There's a lot more to this, but if you have NFTs to represent the base IP, then it means that it's much easier to transfer the ownership of that base IP from one person to the next. You can do it with ERC20, but it's not as easy. So working on that too, I'm actually going to publish a blog post next week, drawing on all my experience going back to Ascribe days. And then more stuff this year, more on Token Spice and EVM, and going to dive deeper on MEV and data. There's a lot of really interesting interplays between sort of AI, MEV, data, and all this, and hopefully ending up at things like evolving EVM bytecode with genetic programming and stuff. That's pretty cool. I'll stop.
That's amazing. Like literally, these 30 minutes, people are going to listen and, you know, twice as slow to capture all of the things that all of you said, like what is happening. And one more thing, literally, so this whole data IP usage and basically collaborating, building on each other's work, but then also taking care that whatever liquidity events happen, sharing that within the network, that should be something we should all get together one more, please. Especially now with the computational law of positive and everything's going on. I think like with everything in this domain, these chance encounters where people, you know, share their signals and we're processing new or current trends come out, which definitely we should find a format for this kind of that you know, that helps also with our scheduling problems and issues. But thank you and thanks everyone for joining. I think this is going to be a great round. I just always have the difficulty to, you know, keep my mind in some sort of a linear structure to help people work through this, because I would love to, you know, jump from one to the next key words that I heard here, but I'm not going to do this. I just want to share something to maybe focus our thoughts on from moment to moment. So this amazing, like everything I just heard right now, I wanted to go deeper on that. But let's keep it to this topic because it's also for the new ones coming in, and it's like, what is token engineering? And yeah, I heard it's transdisciplinary, and kind of this is what I'm drawn here, but I'm drowning. So these are the people we want to speak to, you know, tell them you're here for the right reasons, don't drown, survive long enough to find your foothold, and then let's get this space rocking even more. So we talked about this transdisciplinary art of doing science and engineering, okay? And literally, I always link this one here and the art of doing science and engineering from Hamming. And he is the guy, right? And this has a subtag, it's about on learning to learn. And I think this is what brings us together here, and this whole learning to learn is something I want us to revisit one more during whatever you want to talk about. I know Ocean has a learn track now as well. Maybe that's something we should also go into. But basically, let's recap a little bit, like what are the different disciplines, and just trying to locate you guys here. Trent, AI, optimization, control theory, heavy. Like if I would say, okay, you are all polymaths in my view, but if I would say, okay, this is the one, differentiating petal, I would say Trent is around here. Industrial systems engineering, robotics diagram is around there. Political science, governance, economics, Shermin, and Shermin is the one, in my view, who can really help create a linear narration of all of this craziness that's going on. And that's how I met her, actually, in an energy conference, blockchain and energy conference, and she spoke about the DAO and all of the stories that were unfolding in real time, the people trying to tame that beast that they created, which was code. And yeah, it was amazing how Sherman, how you could put that into context. And I think that's one skill set we definitely also need to nurture. It's like with data scientists, where we say the one skill that you really need to work on in data science is also how you tell the stories with data, because no one is going to look at your cluster analysis, whatever visualization tool you use. So in a sense, and as I mentioned, Lisa, I'm seeing you between economics and computer science, definitely very strong here. So if I would, and my background is computer science, and I'm like, what am I doing here? Is every time I get curious and drawn into one field, I'm like, what am I doing here? Like, why isn't that already sorted out, and so on and so forth. So and when I just stopped fighting that, what am I doing here, and actually trying to make sense of, sense making became a thing that I did the past year, basically, and it was really enlightening, also personally, I must admit. And one area is really this philosophy and ethics. Wassim and Trent went into it. On one side, we have ethical engineering, which is embedded in the engineering, civil engineering. So can we have that? How are we going to have that in such a fast-pacing industry or field? So these are the things that are on my mind. So, and then how do we get to this unity of knowledge, this wisdom that we synthesize together? So,
hey, Sebnem, can I say something real quick? I just
please.
When you were talking about, you found yourself in computer science on the flower, and you keep asking yourself, why am I here? That sounds a bit like imposter complex, and I think that's something that's really quite common when people are jumping from field to field. So I started off as a chemist and a physicist, and now I find myself doing this applied economics and philosophy, and I'm like, well, yeah. Also, what am I doing here? But there's this really nice concept which we discussed at the salon, which we called epistemic trespassing, which I think is actually an upgrade to imposter complex. So imposter complex is kind of like, oh, I'm in this field which I'm not trained in. What am I doing here? But imposter complex, or imposter syndrome, or whatever you want to call it, is more like, I recognize I'm in a domain of knowledge that I'm not as familiar with as my core training. So I will pay some heed to the fact that there are different customs, languages, and norms, traditions in this other place, while I navigate my way through this epistemic or virtual territory. And it's a nice lens for which we can use to navigate the flower as well.
Yeah, I would like to, thank you, Wassim, for saying that, because I think we need a different narrative, this disciplinary narrative of like, it produces imposter complex or imposter syndrome, but it should be the other way around, the cross-pollination. coming with a different perspective, not understanding anything, or not understanding the code and the customs, allows you with an outside view to bring a perspective into a discipline that it might need. So instead of saying like, what am I doing here? Maybe the question would be, why am I here? It's like, what can I contribute to this discipline? And this is much more positive. And I think this is the narrative that we need. We need to ask, like, what can I contribute? And like, not, am I allowed to be here, right? And if we change that narrative, I think that would be the first step. Changing this kind of narrative is like, yes, we're allowed to be in a different discipline, because there is always an intersection. We need these APIs, to speak in computer terms, right? We need an API between the two sections, and this can only happen when people from different disciplines come together. And being different should be comfortable and not uncomfortable.
Yeah.
It's what makes life fun, and it's what should make research and development fun. But the one problem that we have is capitalism. Let's say, like this weird word. It's like this having to produce in a timely manner a result. Whether it's a paper in academia, because I have KPIs at the end of the year, I have to deliver 3 papers, no matter their real quality, right? Really, who produced like KPI driven excellent research? I don't think anyone, right? And the same is true for development. Like you have people who put money into your startup, and you have to deliver a bottom line, and you're always trying to produce you're in this time crunch. This time crunch makes us more uncomfortable than we should be, because very often this interdisciplinary work, whether it's research or development or both, needs time. And the one thing we don't have in those nowadays is time, because time is money, and money needs to be made more. And so we need to change that narrative too. We do need to understand that, and there's a short-term thinking of money and time, right?
Yeah, I completely agree with both of you, and I will add that it's almost a privilege to have a multidisciplinary approach to things, because you have the privilege to look at a situation from different kind of perspectives. Because when you're so specialized in the field, that's all you see. Like Shermin, I completely agree with you. When you speak to an economist, they're like, no, I don't do information systems, or I don't do macroeconomics. I don't do central bank digital money, so I don't know anything about that. Because you're so specialized in your field that you kind of forget the privilege you can bring to the table by having a different perspective to the same issue. And so that's actually fantastic, because as you see, all the flower petals are all very important parts, and together they form up the entire picture of a flower. And one part can't exist without the other, or they come together in a very nice picture. So you're able to look at things from different perspectives, and that's very valuable. Another thing that I do want to bring up is we see a lot of words in engineering and economics in this slide.
I have to.
Sorry?
Yeah.
Oh, yeah. So
go ahead.
We see the words engineering and economics in this slide, and it's very easy to mix them together as in they're part of the same thing. But I think economics and engineering is slightly different, because economics is the what to optimize, and engineering is the how to optimize. And both of them are quite similar, in which they need the kind of general perspective to understand what's going on in the multidisciplinary aspect and perspective. But the way you're going to execute them, the way you go from completely unknown unknowns to known knowns, take on a different kind of route and take on different kind of skill sets required. And I think that's a very interesting aspect to understand. So economics is more of the what to optimize, which will be the systems, the general overview, and why, and also understanding the economic agents and the relationship between them, because economics is a science, but it's a soft science, because we're taking into consideration a lot of behavioral economics. which is what Shermin was saying previously, where she's going to focus a lot more on behavioral economics. Whereas engineering, we view people as systems. It's all about systems design. It's beautifully mathematically defined, but sometimes there are a lot of external variables that you just can't model out. And that's where it gets a bit more complicated and it gets more difficult. And I think that's one of the biggest challenge in token-based systems, because we're basically doing systems design. We're building systems. We're allowing different economic agents to coordinate and cooperate with each other. And the main way to organize this cooperation and coordination is the incentive, which is tokens. So tokens really is a means to an end. And how do you want to use the means to it? How do you want to use tokens to achieve the kind of outcome? Also, it's not just purely engineering and purely math, but also the consideration of the human impact and human behavior and human response to different kind of situations that's going on.
Yeah. So Trent, do you want to take over? Because there are two things that I heard, like goals or what, right? One thing I wanted to ask Trent back is like, and also because now you have a live system and it's third iteration, how do you decide on the what? Like, how do you come up with the goals in the first place? And that goes hopefully also back to engineering or the ethical roots of how do we decide on the direction? Like the design space it's used, we could incentivize all sorts of things. How do we decide on the goals?
Yeah, so on this, yeah, just going back, I'm really glad that people are talking here in this conversation. Several people are talking about the distinction between science and engineering. It's really important, right? Because otherwise we will confuse them and it is counterproductive. So once again, the main goal of science is new knowledge, right? Scientific method, traditionally, you have a hypothesis or you start with a research question. And then you have hypotheses of answers, and you go and design some experiments, and you run those experiments, you do analysis, you make a conclusion, right? And and there's other ways to arrive at answers as well, but that's generally the scientific method. That's a very different thing, a very different set of processes than engineering, right? And in engineering, the definition on Wikipedia is good as anywhere, right? I'll just quote it here. Engineering is the use of scientific principles to design and build machines, structures, and other items. The discipline of engineering encompasses a broad range of other specialized fields of engineering. So overall, it's about designing and building machines, et cetera, right? And it includes maintenance and so on. So the final result is different. The artifact from the process of science is knowledge. The artifact from the process of engineering is machines and maintenance, et cetera, of those, right? When you are doing science, when you're doing engineering, you do have to start with, what are you trying to design for, right? So as part of the process in engineering, you do have to ask and answer the what question. And so within science, you might be doing some what questions, but I think it's really, we have to be careful not to accidentally assign the what to science and not let engineering go after its own what. So in engineering then, a three-step process. You can have many steps, but overall, thinking about process and trying to have some process when you do design of systems, that's the main thing, right? Just thinking about it. And then, so like one breakdown is simply figure out your goals, then do the design process against those goals, and then finally verify, right? And you can do this, and there's, you can put that into the context of a hierarchical design methodology, et cetera, as well. How do you figure out your goals? This depends on the engineering discipline, of course, and within token engineering, a few different people in this room and others have done a really great work on this. It typically involves doing some sort of stakeholder modeling. I've suggested, you make a list of the gives and gets for each stakeholder, right? You brainstorm it, et cetera. And then you kind of iterate against that, come up with checklists and so on. Ideally, at the end of the day, as an optimization nerd, I like to say I want a list of objectives and constraints, right? Things you want to maximize and minimize, or things you want to solve for. But there's just various framings. As long as you have a process towards, defining your goals as clearly as you can, knowing that there can be ambiguity, and then actually designing against those goals, stopping as soon as you can. Don't optimize for novelty unless that is really another objective. Because new novelty adds new risks, so don't do it unless you need to. And then finally, you know, stop verify. And verifying might mean using some software tools. It might mean just getting your friends to review a white paper. There's a lot of different things there too, right? So each of these steps has a rich set of ideas and thoughts, but I'll stop there. And I think that's a good way to think about it, right? Goals, then design, and then verify.
I would like to add something to what has been said before as regards to social sciences being soft sciences. Social sciences so far have been soft sciences because we didn't have the data. What makes our new economic kind of the Web3 so special is like, we're already in the Web2, we have so much more data than we used to have in the analog world. So we have these emerging disciplines of computational social science, and in the Web3, we have real-time data, public real-time data of all activities that happen in a social network, such as Steemit or other Web3 based social networks or advertising networks, etc., or computing networks such as Ethereum, and having this real-time data of who is doing what in the network and having that publicly will allow us to steer economic systems and redefine also social sciences as soft sciences as we're moving in those so-called soft sciences towards more steerable data-based sciences that I don't think will be soft anymore as they become so computational. And so yeah, we definitely need to redefine what a soft science is in a data-driven economic system. And one of the challenges we're seeing right now, and one of the challenges I had in my research and project work while at the university, was that those disciplines, people from the so-called soft sciences, even if they were quite kind of economists, are quite good with math in theory, but it's not the level of math that, you know, it's not the maximum level of math there exists, let's say, right? And so they couldn't, and they didn't understand the data-driven, like that. Basically, the Web3 and tokenization, tokens are the atomic unit of this Web3. And they come with so much metadata, and we can now use this metadata to model any type of economic system and understand the behavior of the parts of the different systems, whether it's human behavior or any other type of non-human flock behavior. I don't know. Yeah.
Exactly. And basically, you know, computational anything, right? And the things that we design become part of the network, and literally, you know, we need to have this data feedback, like what is actually happening with whatever we designed in the live network. And again, one more back to
and I'm sorry, I would, sorry, because I think that's important. What Lisa said, I'm not sure I agree. I think we need to discuss this more, and maybe we can't do it now, but I don't know what you mean between the difference of engineering and economics. I don't think there is a difference, other than that up until now, economics didn't have the data. So they were they were working with old data, outdated census data that was maybe 10 years old, to model the economic systems of the next 10 years, right? It's become better in the computer era, but as we're moving towards data-driven economic systems, we need a new set of economists who are more of engineers who can work with the data that they have, who understand network science and data science. And I think that the field of economics will shift in its tool set, and we will need completely different type of economists in the Web3.
I would comment that.
And economists who are more engineers.
Yeah, it's a really great question, right? Is economics engineering or science, right? And it seems that it's a bit of both. And so maybe as a heuristic, if you happen to be calling yourself an economist, know if you're doing engineering or science on any given day. Are you trying to produce an artifact or knowledge, right? And I think traditionally it's been really hard because of lack of data, right? Like maybe you work with the government for 20 years to roll out an economic policy. And so it's an experiment that you don't really have some way to test against it some other way, right? So there's sort of long-running experiments that are very hard to experimentally validate or invalidate and stuff, right? But of course, that's the more broad stuff, and that's just one type of economics. There's a bunch of other ones that are more narrow, et cetera, et cetera. So I don't know, but I'm not an economist, so that's just my non-economist view of economics. It could be completely wrong.
No, I think you're right. So if you're, as economics is becoming more immediate and more applied, they will have to choose to be more an engineer, hands-on engineer, or more a scientist, probably. Yeah, I probably
think
agree
economics,
with that.
there's two different fields. You have applied economics and theoretical economics. So that's basically where the differences lie, where you have the economics as in the science versus the engineering.
Right. And actually, here's a question then. Is applied math science or engineering?
Depends on the how.
Applied.
Yeah, so.
Yeah. So anything that's applied needs to have a process and a how, and that's how it becomes kind of engineering. And right, am I on the right side of a possible answer that would pass?
Probably. And
there's a question.
Yeah, go ahead.
There was a question from Josh. I just read it. Is economics not theoretical only, or no, it isn't. Unfortunately, it isn't. It shouldn't.
No, it is not.
There are a lot of economists sitting in policymaking positions, steering our economic system based on outdated data and outdated concepts of how the economy actually works. So unfortunately, they're not only sitting in the ivory towers of academia, they're shaping our economic systems and not very up to date, in my opinion.
Yeah, let's also say something about like economics culture, like in the ivory tower, in the policy space as well. Because I saw one of the things I was doing when I was working on the Cryptoeconomic Systems Journal at MIT was trying to bring in people from like the National Bureau of Economic Research, like a high-level policy think tanks in the US, trying to bring in like Ivy League economics professors to this kind of crypto economics milieu. And we often found that it was hardest to bring like law professors. They could see the value and the kind of necessity of stepping outside of their kind of like the incentive structure, which is aligned in their particular segment of the academy. Computer scientists were also a little bit more, open-minded. Economists, we found it was actually hardest to get them involved. Like their ivory tower seems to be the tightest shut. And so like there's a comparison I used to make where if you compare the life of a career and the life of a professional life of a law professor versus an economics professor versus a computer science professor, and it all comes down to publishing and getting your work out there. But for an economist to get tenure, and especially in the States, they basically have to publish in one of 6 journals which has existed for 100 years or older. Yeah. You basically have to get tenure off one paper in one of these like dusty old tomes, and that's just kind of how it is. And so there's this tremendous amount of inertia and resistance to change. And I think that's also reflected with the economists that were trained in those ivory towers that end up doing all the think tanks and the policy stuff in DC and case and all this stuff. Maybe Lisa sounds like she can speak.
I'm going to fight a little bit for economists, and I'm just going to say that there are a few things to think about. Like economists are very like ROI driven or optimization driven. I mean, that's something that given if I go to a supermarket, I spend a lot of time in the supermarket deciding which ingredients to buy that will give me the most ROI in terms of cost spent and in terms of what I can cook, in terms of how I can use the ingredients. So it is just kind of in our behaviors, and my friends who are all economists, they also behave kind of like that. So I think there's some behavioral things that we all need to fix as economists. So the ROI to work on these policies or come down from like the ivory tower, it's quite difficult. Like the ROI is not there. Secondly, usually when economists are in the space working, they usually go by another name. They're not called economists, they're called something else. So you don't put them in the right category. And the third one, which I guess is the biggest problem, is because I work with a few like policymakers or we did different kind of research to be advising on how to change policies, right? Because a lot of what economists do is to run research, to get empirical study, to figure out what kind of policies will be the best suited in the long run perspective. The thing is, there are two things. The first one is it's a really, really, really long run. And in economics, you know, the long run we're only there when everyone is dead. So you can't really account for that because the policy is it's so far ahead that you just can't calculate the present value of that. And so that's difficult. And the second thing is a lot of the time, because economists think in a very different perspective, that a lot of policymakers, it takes a long time to convince policymakers to adopt this policy, that it becomes quite tricky and difficult to go into the policy field. And it's easier, like it's honestly easier just sitting behind a desk writing papers and coming up with beautiful theoretical models than to really go out there and do the deed, because it is just kind of complex, complicated. And, you know, in the assumptions world, everything is just pretty perfect with ceteris paribus. In the real world, you don't have that. And that's just not so fun to model after all. I think one question I want to throw out to you guys is, considering that this is multidisciplinary and you guys are all polymath, what was a field or what was a discipline that shocked you the most?
Very good one.
Shocked as in what?
Yeah,
like
so for me, it was
or...
biology. So I didn't expect, so I was reading a book on genes, and I didn't expect I could get so much out of genes and biology that couldn't be applied into adaptive systems. So how can I take how cells evolve, how cancer cells, using game theory in cancer cells, or the analysis of game theory in cancer cells, being used in developing economic models and economic systems? That was very surprising for me.
So
go ahead.
Yeah, like for me as well, philosophy, law, ethics, that was the one. I'm like, but why aren't lawyers, you know, why are just lawyers doing their job and you know, don't do this fundamental, the fundamentals of decision making in any ways. So that was philosophy, law, and ethics was the one that blew my mind and then changed a lot of wires, rewired a lot of things in my brain, for example.
I can, you know, in my first year of engineering, we had a class called Linear Systems Engineering and Design or something. And, you know, we had to write down differential equations, and then we had to instantiate that system as a thermal system. And then we had to instantiate the same system as an electrical system, and then a mechanical system, et cetera. And we had to go back and forth among these different representations. And I really loved that, right? Because we got to span disciplines and understand that, you know, you could realize these dynamics in various media. And that, of course, it's linear. So you have, you know, a small perturbation means a small change to the output, you know, and so on. So, and once you get to nonlinear, then you can have things drop off a cliff. You know, a small change can lead to a small perturbation can lead to a large change depending on the dynamics. And so generally though, like engineered systems tend to be where they try to be as linear as possible, right? Including analog circuits, et cetera. Although even in analog circuits here and there, you have some weird nonlinear things that people learn to wield like Jedis, right? And analog circuit design is actually often called an art form too, just like token engineering and some of these other harder disciplines. So the thing that surprised me the most was that if you start to think of if you think of crypto primitives, not cryptoeconomic ones, but crypto ones like hash functions and encryption and stuff, they're super nonlinear, right? Like the field of cryptography, if you think of it as a bunch of building blocks for token engineering, there's like no linear functions. It's all super nonlinear, and it makes it really hard to design systems with and compose them, right? So you kind of have to mix and match the building blocks in a bunch of random ways just to come up with anything. So anytime someone comes up with a new design, it doesn't feel like logically designed in a sense almost. It's just kind of something that magical that came out. Sort of like, you know, Bitcoin is a good example, right? Combining a few other building blocks. But then the ones before that too, right? How public key cryptography came out and Diffie-Hellman key exchange, et cetera, right? All this stuff, it feels some sort of like magical combination of things. And that's because the building blocks themselves are so nonlinear, right? So that was the biggest surprise I had.
Cool.
Shall I go?
Yes.
So I guess for me, it was closing. I'll try to do something. I'll not cover some ground that everyone else has covered. So for me, it was closing the loop back to physics. So, you know, I misspent my 20s doing physics, photophysics. So I was playing with lasers, which sounds all cool and exciting and sexy, but until you realize that in the laboratory, if you have lasers, you can't have reflective surfaces. That means no windows, not even any polished surfaces. So I spent my 20s with like vitamin D deficiency, sitting in a dark room in the center of England, and so we were studying we were using lasers, which are the outputs of quantum processes, to study very fast, short-lived, photophysical quantum processes happening on these like femtoseconds and picoseconds, extremely short timescales. And so I was really in the weeds of time. In the weeds of time and in the weeds of all the kind of the weird quantum world, like things that aren't certain, things that you think you can know in the real world you can't know, or you have all these kind of new limits and new ways of that you have to kind of get your head around things. And so for me, like I suppose it was seeing the ways of thinking that you use to try and understand quantum systems, both when they're singular and in aggregate. And I think that speaks a bit to Trent's point when you're talking about systems evolving. So systems are not just made up of one thing, they're made up of like loads of entities, and these things don't all have the same set of parameters very often when they're in the wild. They might have you might have a normal distribution of your like energy of your molecules, or the balances of a bunch of AI bots running on ocean, or whatever it is, right? So try to think in those kind of ensemble dynamics ways, whilst trying to take into account things like contingency and uncertainty and path dependence. That I think that goes basically philosophy of physics. Like I was interested as a teenager, and I come back now and I see where we are now, and I'm like, oh, this is really super useful right now, right here, to try and square all these kind of like the disconnections between these disciplines and ways of thinking. It's like plumbing. It's like what we're trying to do is we're trying to plumb all of these different pipes together and try to pull tools from everywhere that we can.
And deal with this complexity of non-linearity in a conscious way. And actually, there's this non-ergodicity economics. You guys know, like literally
Peter Ole.
Yeah, exactly. That kind of draws on the same core of things, saying actually many of the standard economic models that pass as theory and are taught are linear, simplistic, or truncate the complexity. And so a lot of the things that you just mentioned draw back to that.
Yeah, and for me it was the intersection, I think flock behavior, and what you like the intersection of biology, physics, and economics, and tying into the non-ergodicity. I always have problems saying that. Yeah, there is so much we can learn from biology. In economics, we don't have to reinvent the wheel, and physics, and we don't have to reinvent the wheel. So I think, and now with graph theory also becoming a big kind of tool as set in the toolbox of modeling computer networks and social networks, right? And understanding and modeling social networks. I think what has happened in the Web 2 and the understanding of social network and behavior in social networks, we can take that and build up on that. But we definitely can learn much from biology and physics. Yeah. So that was maybe not so much of that was probably the biggest surprise. Yeah.
I completely agree with you guys. I think biology and physics are the rules that is embedded in the natural world. So physics are the rules that's embedded in like gravity and everything that we interact with, and biology are the rules embedded in the molecular level of how systems work in the natural world. And what we're trying to do is to take these algorithms or these processes and simplify them or take lessons from them so that we can embed them into these digital systems or these new systems that we are creating. We call them economics, we call them economy, we call them engineering, whatever, but we're taking answers that's already out there in the natural world and adapting them to a smaller micro little universe that we are creating from scratch. And that's where I think the whole interdisciplinary comes in, because we realize that the answers are everywhere. We just have to take the right kind of answers, ask the right questions, and then put them together in a little box. And then that's our little economy. You have tokens or not, doesn't matter, because it's the other mechanisms and processes in place to define this little world that we're creating.
So, and I think complexity economics is the field that goes furthest into this direction, because it is on the intersection of many different types of social sciences. So I think Web3 should build on what complexity economics has started. It's been marginalized. It's considered super heterodox. Because it's not simple enough to do policy making in a nation state. But I think as we're moving towards a digital world and more data-driven world and more interconnected world, we have to say goodbye to the old ways of policy making. And I think with this pandemic, probably, it's becoming much more obvious, the interrelatedness that a lot of people in our society try to negate.
So I have an opinion that is maybe controversial. Maybe that's useful for the discussion here. So if you're designing a circuit with like 1 billion transistors, you don't design it as this giant sea of transistors. You have a bunch of subblocks, and each of subblocks, etc. And each subblock might have 10 or 100 transistors. And even within those, say an op amp or a filter or something, you try to have well-defined APIs. In circuit land, it's called high impedance inputs and stuff. But you engineer these things so that they have these high impedance inputs or well-defined APIs to minimize coupling among the different designs, right? And this is very important. So when we engineer systems, we can design these building blocks such that they can fit together like Lego blocks better. This is different than celebrating complex systems. In fact, we are trying to avoid complex systems. We want to build complicated systems, but not complex ones. As soon as you have complex, the rules go out the window and you have crazy dynamics, and it's really, really hard to do. So you can have some emergent behavior in some places, but you have to be very careful about applying it in just the right places, and everywhere else, make it high impedance, make it have well-defined APIs and so on, because otherwise you're dead in the water. And if you try to mix complicated with complex, you're really dead in the water. So I worry that, just bear with me, I worry that the field of token engineering celebrates the word complex too much, and it's the wrong direction because it scares people away. And it also is counterproductive to designing designs that work.
Yeah. So can you go into like when you say complicated?
But to tie, wait, I would like to answer. So I think here, what you said before would apply very well. On a theoretical level, we do need to talk about complex systems because it's a thing, right? But I do agree that on a practical level, we have to try to reduce the complexity, right? But not by simply ignoring that it exists. And I think that's what we are trying to, because we come from a tradition in the last decades of decomplexifying science and development, which is understandable, right? It has been lost on people, the notion that in the end things are interconnected with each other and creates system dynamics if we don't try to make them complicated. Instead of simple, they will become complex because they're interrelated. Do you understand what I mean?
We are confusing two terms here. Generally, when you're designing engineering systems, you do want to minimize complexity, right? The degree of complicatedness. But that is a different thing than the phrase complex system. Complex system means something that might have very simple rules, but has dynamics that emerge that could be like super nonlinear, super chaotic, etc. This is what we want to try to avoid. And wherever we have it, we need to put it, bound it with a box with a well-defined API so that we can actually work with that building block. But what we shouldn't be doing is saying token engineering is about the design of complex systems, because that is going to cause tons of problems going forward.
So this is, I think, where the rubber hits the road. Like, totally agree that it should be as simple as possible, but not simpler. And we don't have time, I think, but maybe, like, could you say what you mean by complicated? Because I think, like, if you add a lot of simple things and add features to fix things and add features to fix things, you can get a complicated system that is a mess. And it's gonna, and what I think, when we say complex system is like just that we know this thing out there is a complex system. Even if you have the simplest token design, you put it out there on a global ledger where other smart contracts can interact, or people can build other systems on top. you know,
Yeah.
there will be reactions.
Yeah, so let's think about a circuit, right? If it's got 1 billion transistors, it's just complicated by the nature of so many transistors. But somehow a team of 15 engineers can build that and ship it with confidence with one silicon spin in about 3 months. How is that possible? Because they have well-defined APIs, they follow a hierarchical design methodology. The building blocks that they have talk to each other, right? So you've got maybe 3 or 4 levels, right? At the lowest level, you've got transistors. 1 level up, you've got op amps, filters, etc. 1 level up, you've got radios and memory circuits, etc. And then at the very top level, you've got your overall system on a chip, right? And so this overall system is complicated, but there's well-defined interfaces, and any given building block maybe has 7 to 15 different submodules. Or maybe you have like 100 modules, but they all just repeat, like a bunch of memory columns in a memory circuit, right? So that's what I mean by complicated, and not complicated as in hard to understand, complicated as in a lot of pieces, but put together in a way that is where things are easy to model, easy to engineer, easy to, that behave in a well-defined way, right? And we want to avoid things where when you connect block A with block B, you get weird nonlinear dynamics, unless, you know, maybe there's 1 or 2 places where that truly does happen, but we want to avoid that. You know, in analog circuit land, you do have these pieces, but they tend to be at the lower levels, and people try to avoid really changing them in big ways because, and you have this in aerospace engineering too, right? With you know, small airplane parts. So we have these cryptoeconomic primitives at the lower levels. They're super nonlinear, that's fine, right? But let's not propagate that to higher and higher levels and celebrate those as complex there. Let's put them together in ways with well-defined APIs that we can model and engineer.
So well-defined, transparent,
I fully agree with that, but we can only do that knowing that if we don't do that, we are in the territory of creating super nonlinear complex systems. So basically what you're saying, like, I think why it's important to point this out is that there is in economics and engineering have very different histories, right? What you just described was the history of kind of a brief history of engineering and how to create complicated systems that are not non-complex, right? But in economics, we haven't had this development. So I think what you're pointing out is but what we had in economics was that a bunch of people trying to reduce economics to oversimplified methods. And then things spiral because you're pretending to not be kind of steering a complex system when in fact you are. You're using kind of oversimplified tools to steer an economic system, and you're completely ignoring the rest. And then you call everything a black swan event, right? That could be, you know, and many of which are not that very, very black swanny, I would say, right? If you wouldn't reduce your tool set to oversimplification, but that is true for economics. That wasn't true for engineering. So what you're saying is very valuable to bring this into kind of the economic design of the Web3. We should learn a lot, and I think I was very inspired of the talks and the first blog post you wrote about economic or token engineering and bringing this engineering perspective to the Web3, and I think that's super important. But we have to understand the economists as they're trained today. They don't understand that most economists, unless they come from complexity economics or ecological economics, they don't want to oversimplify things either, but you're battling this neoclassical economics is super oversimplifying, and it's a really bad beast.
Right.
And this is why we're stressing so much this word, complex systems, not because we believe that in the applied kind of modeling, you want to create, you have, you know, there you need solutions, and there we can learn from you guys, right?
Right. I think that's a really good point, actually, right? That, you know, it's coming from a different angle. And so maybe, you know, the way that I'm talking about this is this sort of a warning in the sense of we don't want to accidentally have people go down the path of celebrating complexity, right? And obviously it's about minimizing complexity, but because you and I, Sherman, have been operating on 2 slightly different definitions from different angles, I think I recognize what you're saying and vice versa, so that's cool. I should also acknowledge, you know, from the land of circuits and stuff, you generally don't have much emergent behavior. right?
Yeah,
in most circuits.
exactly.
So that's a thing. That said, there are certain disciplines that have that. And I spent a lot of time in the world of evolutionary computation, evolving stuff. And that is where you are engineering things to have emergent behavior and so on, right? And that's actually even in the blog post that I write about that, because I think it's probably, you know, in my experiences and the things that I've seen, it's super useful set of tools, right? And the things at the very core of that too, they're hard to model, they're hard to work with. They're kind of, you know, not such good building blocks. And trying to wrap them into orthogonal modules has been really hard over the years and stuff, right? And then bringing in the bio-inspired stuff, I'll be honest, it's been counterproductive, because, you know, you maybe get a 5x or 10x by getting inspired by ants, but then you don't have progress in the field for 10 years. And you know what, when you get progress, when people realize that ant systems were just reinforcement learning, and then reinforcement learning is control systems, and then you can draw in control systems techniques. And as soon as you realize that, you make 10 years worth of progress in 1 year, right? So overall, what I'm saying is there are some fields that, you know, can be helpful from AI, and, you know, connecting the disciplines, which is, you know, probably everyone in this room, like as we've talked about, is really good at this. So that's the thing to do, right? And try to bring it to the fields where you can build on top, right? Bio-inspired is cool to get inspired, but to build on top of that, it's really hard. So you have to loop the bio to the math, to the differential equations, etc. And then you can really make serious progress.
Oh, maybe I could just jump in real quick. And so in the Zoom chat, I just linked a paper which came out not so long ago. So the Santa Fe Institute affiliated author talking about the paper's called Economics in Nouns and Verbs. And it's arguing that in its formal language, as it exists now, you know, at least the kind of legacy disciplines of economics lack some of the semantic tooling in their formal representations to describe dynamic processes, algorithmic type processes.
Nice.
Everything is like, yeah, everything is basically like, as they say, it's nouns. Everything is like a gamma or a rho or an A or a capital B or a whatever. It's a fixed static thing that they're trying to, and so they reduce down the formalisms to these kind of time independent structures. And coming back to the point I made about quantum mechanics as well, there's almost like two completely different kinds of quantum mechanics, time dependent and time independent. And so it's like to fold time into the thing kind of required the reinvention of the formalization of the field. And I wonder if this is, the paper is kind of calling for that in economics, which speaks a lot to Trent's points as well.
Okay. So
can I jump in a different perspective, actually? Is it, do you have time?
Yes, say again, please.
Okay, if I can jump in and offer a different perspective.
Bea, hey, sure.
Hey.
Go ahead. Bea is the artist, so she knows about the art. And she has great experiences with token engineering and applying it in her community of art as well. So please, Bea.
Yeah, so not coming from engineering or economics. And what is interesting to me is that obviously Shermin and Trent, both of you are very valid points, right? But from my perspective, it comes from either theory or actual engineering and emerging engineering systems and behaviors and emerging behaviors. But because we don't have those tools, and the tools that we actually have are imagination mostly, and lack of conventions, right? Like we don't really follow any conventions. What we actually do is to observe the complexity of our own dynamics in our community. And when you see it, that's a completely different process, right? It comes from, it's extremely complex. And instead of trying to simplify that, what we actually do is just to observe how we interact with each other. What are really the dynamics going deep into understanding when things work? What is it that is making it work, right? What is the structures? Like that's a really difficult thing to see, to do. Like what are the insights that are making something that you don't even understand the words work? So we have things like, and Sebnem knows this, right? Like we're saying that like we've been designing this economic without ever making a decision, a vote, and it's collective. And so when you think about those things, the first thing that you will say, well, how do you do the voting mechanisms to make decisions? But you realize that in this ecosystem, we haven't needed not even once to make a vote to make a decision. So instead of going from, you know, because it's the kind of system that no economist in the right mind who will have vision, right? And so I think what we need is all kinds of perspective, and philosophy and ethics and artists and people who with imagination, and then the people who can actually build these things and make them work. But I will just like offer that like Paul Krugman says that economics is about people and what they do with their income. I like better the definition of Michael Alberg, which is economics is about people and people interacting with each other. It doesn't even have money in the equation. And so that's, I think, what is really like when we have to change our mindsets so that we actually produce something different than what we have so far.
Yeah.
Thank you.
And that's basically the crux of it, like because we're not designing for machines, so for those to work, and we're not designing on fixed infrastructure, the design of chips and materials. So this mechanistic and materialistic scientific view that works wonders, no question there, right? I mean, the chip designs and so on, like the fact that we're having this conversation on a networked computer, it has taken decades, and it has taken the scientific, materialistic, and mechanistic approach to succeed. But right now, I think all of us are aware that these systems can actually level us up in our humanity and how we're interacting with each other. Like all of these systems, the scienticism, if you will, or that we had looked at, at everything like machines, that had devastating side effects as well, like this dehumanizing, side effects of capitalism.
Scientism is a real word. Yeah, it's kind of like the dirty word that is cast back at the capital S, science, the Church of Science, the institution.
The Church of Science. If we and then basically it brought us. I mean, no question there. Like literally, this productivity, getting things done, and then also knowing what you're doing, etc. But we're at a space and it's a place, and we have this beautiful connected community of diverse backgrounds where really every perspective is valued, and we love this happenings coming together and exchanging the perspectives. And I think our common, effort right now is make it work for everyone, right? Get this language issues in order, get it in order that we actually say everything starts with the first step, and get that step right. And these are the processes that you can follow. Like anything that comes from Trent's corner about this, how can we really make this to practice, from purpose to practice. That's where we, I think, all of us have our hearts and heads in. And I just have to say, I mean, we have 3 minutes left. And I just want to say, like, thank you for making time. Thank you for sharing your insights. It's been a great ride. Through the ups and downs. I never looked at prices, but always at your posts and tweets and anything you share. And that's made all the difference. If you have anything you want to share, just or where people should look next, let's have one small round. Wassim, do you want to?
Sure. Gosh, where to start? So we had a conversation about non-fungible tokens at the salon earlier this week, and we are about to do our first audio report. So we'll put out something like a podcast based on this conversation. And there are a bunch of people that we all know very well in the room. So we mixed up kind of token engineers with philosophers, media artists, design critics, for everything, and I'm really pleased to report that we didn't get stuck on any of the kind of like the really basic tripping points with NFTs, like energy consumption or whatever else it is. We actually got onto some quite interesting stuff. So keep an eye on the 0x Salon website for that, 0xsalon.pubpub.org. I guess that's what's coming next. Cheers.
Thanks a lot. Shermin?
I don't know. There's so much there is so much information currently out there when it comes. Yeah, I think.
Shermin, you're on mute.
Or did we lose her audio?
No, I think it says she's muted. Yes, she's muted.
Shermin.
You didn't hear me?
No. Like, I'm going to say something.
Thank God you didn't hear me. I was rambling. Okay, I think I love Wassim's salon, so I can second that. Probably all of his all of the episodes. If you want to be more on the philosophical, theoretical side,
How about
I don't know if you want what I can we have our paper for those who didn't read it. It's also quite theoretical. More practical would be probably what I'm currently writing, and I will be pre-publishing my book chapters. I will be analyzing token use cases one by one and dissecting like how it works, who are the stakeholders, what is the system steering, what are the crucial engineering questions around it, it will be a mix between, probably the blog post will still be quite descriptive. In the book, it will then be more also with a analytics tool set. And the idea is to help identify best practices and worst practices of token engineering with real world examples. Move away from the theoretical that I've been moving like in the theoretical field, but really take real examples. I think that's the best inspiration for token engineering from my experience. So I'm trying this now. Yeah.
Thank you.
So follow me on social media if you're not doing that already. Yeah.
Fantastic. Keep it coming, keep it flowing, Shermin. Thank you. Lisa, do you want to share anything, last directions where people should look
absolutely.
into?
So if you're interested in the education space, there is education.economicsdesign.com. There are a lot of links over there with a huge research list that I have, a resource list where I find all the different research materials, papers and videos and content from all around the web for the past 3-4 years. It's all over there. There's the academy that I'm building. So just go to education.economicsdesign.com. All the links are over there. Looking to build a bootcamp, looking to get more courses. This spring/summer, going to launch a DeFi course, updating the book, probably going to make a book version 2 soon. A lot of things around the education space. But if you're interested to contribute in this space, an area you can look at is something that Trent spoke about earlier, which I think if we have more time, we should definitely talk about that, is the ethics and morality, and how do we ensure that when we are designing these systems, because we're basically designing a brand new world, designing a brand new planet, how do we embed ethics and morality into the design? Because ethics and morality was something that I think the legal space failed, because it's not illegal to be immoral or unethical. But if we can embed these kind of systems or these kind of concepts into systems and into systems design, that will actually be a very good step forward, because we're using technology to improve the existing inefficiencies that we have in the space. So that's something that you should definitely look at.
Love that. So actually one of the chapters of Token Hitchhikers is an interface to moral philosophy for token engineers, right? So Jessica was also in the call, or is in the call. I think she's gonna lead the translation of this big transmission that we had from Fabian. And would be great if we connect on that one more as well as a round. And Trent, from your side, how do we get started? Keep it real, keep it simple.
Yeah, these things, I mean, you know, after I wrote those initial articles a few years ago, I realized the best way that I can contribute to the field is to have, you know, a real world design, a real live all that, and just apply. And then sort of reports from the field, the really pragmatic stuff, right? So I always wanted it to be one of the best in case examples of that. So you'll see that the blog posts, I typically write 3, 4, or 5 of them a year. They're very token engineering oriented. So there's follow-ups, you know, every year of these things. And, last year I wrote pieces on, the Web3 sustainability loop, which I think is a really nice pattern for token designs, and more projects are adopting it, or token engineering verification. And this is drawing on, what we've done, but also practice from others. So you can check out, just blog.oceanprotocol.com, the pieces by me, that's a place for that. And I guess for people to get started, right? Yeah, don't be scared. Like if you're an engineer, especially, then just dive in, start playing with Solidity, start building and all of that. And if you have interest in AI, there's actually about to be a Cambrian explosion of AI and blockchain in a big way. Because what's happened is in the last 3-4 years, about 5 or 8 really, really great teams at the intersection of AI and blockchain. A few years ago, they started building. Now these systems are finally coming out in the last half a year, 1 year, right? So, there's us, there's SingularityNet, there's Fetch, there's several others, right? And then other teams are starting to leverage optimization more, right? Like Balancer is putting optimization as part of impermanent loss, working with Gauntlet, which is also doing great work at the intersection of optimization and token engineering. So what I'm saying is, and related to this, right? Like bots are customers too for token engineering. Right? It's not just for humans.
The APIs, yeah.
And machine to machine. So there's tons of opportunity there. And the big problem, sort of the elephant in the room problem in Ethereum land right now is MEV, right? And so what can you do in token engineering and AI, et cetera, to help solve MEV? And there's a lot of really, really interesting directions there. So I'll leave it with that, right? If there's one problem, if you're an engineer and biased to AI to go for, use TE to help MEV.
Okay. And can you spell out the acronyms?
Miner extractable value. So it's like if you're running a miner, you get a bunch of transactions coming in, and if you're smart, you reorder them and insert some of your own and run arbitrage and Uniswap and Balancer and other stuff at once, for example, right? So there's different ways that miners, just simply by reordering transactions or delaying transactions, et cetera, can yank out value, and that's value that is taken away from other users in the system trying to do more. It's the blockchain equivalent of front running, right? By the hedge funds running big computers next to the trading floors, right? And so it's just emerging now. In the last half year, it's got a lot more sophisticated with the rise of DeFi and DEXs. And so it's going to be an arms race back and forth, right? But it's a wonderful field for token engineers to play in. Here we go.
Amazing.
Great.
Amazing. Thanks everyone. And as a complementary opposite to that, Bea, you heard Bea speaking. She's from Dada.art, the community, and builds with others, co-creates the invisible economy. And that literally goes to the point of, what if all of this is for us to automate all the things that we don't want to do as humans and have free space to connect as humans? How would we build systems? How would we build things? How would we build community and live in it, even across the globe, connecting through digital media? So this, again, I think the application domains and the people in this space are just fabulous. And I hope everyone new listening to that got some kind of a foothold. If not, come to Token Engineering Commons or Token Engineering Community Discord, ask, and people will everyone is happy to, reach out a helping hand and get you to your first step in the space. So with that, I would say, thank you everyone for making time. I know it is super, super valuable that you do that. So take good care, and we'll share the recording.
Thank you, everyone.
Thank you, everyone. Bye.
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 Bye.